Hello, and welcome to today's lesson on section 4.3, day 1, and this is going to be parallel lines. All right, you can put your date up here, all right, your name, all sorts of normal things that we put up in the corner here. All right, so today we're going to learn about parallel lines. Right, so we're going to start off, you can fold your paper in a hot dog and a hamburger. You're going to need 8 different sections. All right, we're not going to use all 8, but just want to make sure. So even if you think we have the line down the middle here, all right, and we have a line about here, all right. So the first part here, we're going to talk about what are parallel lines. So we're going to say that 2 lines in the same plane that never intersect are parallel lines. All right, so I'm going to underline this and highlight it to realize that's the key word we're looking for here in the definition. It's parallel lines. All right, just so you can see it, sometimes you might see this symbol. All right, I might write the symbol, Mrs. Harmon, Mrs. Pasillo might write the symbol where it looks like it's just kind of 2 L's. That's the symbol for parallel lines. All right, and I just remember because the 2 L's in parallel there. All right, some other things that we know here, right? We can also say that 2 non-vertical lines, all right, are parallel if and only if they have the same slope. All right, so that's probably something that you guys would realize before, that you know that 2 parallel lines have the same slope, all right, which will mean that they'll never intersect. All right, there's one other piece of information that I want to write here, all right, just to kind of make sure, because this says 2 non-vertical lines. All right, so I'm going to make a note down here and just say all vertical lines are parallel. All right, so if we have any vertical lines, they're always parallel. And just a little reminder, that's because of Vux. Remember, vertical lines have undefined slope and they're always x equal. So if you see x equals 3 and another line of x equals -5, these 2 lines here are parallel. All right, just so you can kind of understand it. That's because all non-vertical lines, all vertical lines are parallel. All right, so now we're going to see some examples here. So example 1, all right, is going to be identifying parallel lines. All right, so I'm going to label this one example 1, all right, and I'm going to tell you that line A has the points of -4, 3, and the other point's going to be 1, 2, and line B has points -3, -4, and 2, -5. All right, so if they give us an example like this, we're going to need to remember our slope formula, y1 minus y2 over x1 minus x2. That's an x1, I'll just make sure you can see it. Okay, so what we need to do here is we need to make sure that we label our points. This is my x1, this is my y1, this is my x2, this is my y2. Okay, so the first thing we're going to do here is we're going to find the slope of line A. Okay, so when we do this, we're going to use our slope formula and say y1, which is 3, minus 2 over x1, which is -4, minus 1. This would be 1 over -5, so the slope is negative 1/5. Okay, if we think about it, the slope of our second line would have to be negative 1/5 for these lines to be parallel. So let's go through. x1, y1, x2, y2. So now we're going to say slope of line B. Well, we would say negative 4 minus negative 5 over negative 3 minus 2. This will be, remember these take us a positive, 1 over negative 5, so the slope is negative 1/5. So we can say here, line A is parallel to line B, okay? And that's because they have the same slope, okay? Our second example is going to be the same, all right? And this can be any type of problem we have. So we're going to say line C has the points negative 5, 3, and negative 6, negative 1. And line D is going to have the points 3, negative 2, and 2, negative 7. So we start off the same way. Let's find the slope. Oh, that's kind of close there. It's not MOF. All right, it's going to be slope of line C. Here's our x1, our y1, our x2, our y2. So we would say 3 minus negative 1 over negative 5 minus negative 6. Once again, here we have our double negative, which makes us happy. Same thing here. So the slope is going to be 4 over 1. All right, 3 plus 1 is 4. Negative 5 plus 6 is 1. So the slope of line C is 4. Now we need to find the slope of line D. Here's our x1, our y1, our x2, our y2. So we do the same thing. y1 is negative 2 minus negative 7 over 3 minus 2. Double negative, which is great. So that's going to give us 5 over 1. So the slope equals 5, or 5 over 1. So in this case, line C and line D are not parallel. All right, why are they not parallel? Well, if we look at it here, they don't have the same slope. Line C has a slope of 4, and line D has a slope of 5. All right, so they will not be parallel, and that's all we need to say there. This could also be examples of, they just give us a graph and we can just use Pythagorean theorem and count the boxes. All right, either way works. There's a bunch of different options you can have here. All right, so if we turn our paper over to the back now, all right, we have the same thing. All right, this is going to be example 2. Example 2 is going to be writing an equation of a parallel line. All right, when we write an equation of a parallel line, we're going to write it in slope-intercept form. So we need our M and our B in order to do this. So example, I'm just going to call it 3 because we've already done 1 and 2. All right, I want you to write an equation that passes through three, 1 and is parallel to y equals 3x plus 1. Okay, So there's a couple things I like to do. Well, we know here that we're trying to find a parallel line. So I want to know, well, what is the slope of my original line? The slope of my original line is going to be 3. All right. Now I want to know, well, what would the parallel slope to that be? Well, the parallel slope to this would be is 3, right? Because remember, parallel lines have the same slope. Okay. So we now need to find our b. Well, if we look at our equation, y equals mx plus b, we now have an m, but we need an x and a y. That's where our point comes in. 3 is really our x, and 1 is really our y. Okay, so we're going to plug all those in here. So we're now going to say 1 equals 3, which is the slope, times x, which is 3, plus b. We can now solve this for b. So we would now say, well, 3 times 3 is 9. We're trying to solve for b, so we subtract 9 on each side, and we get negative 8 equals b. Now we have enough information if we look at our slope and we look at our y-intercept to say the line that's parallel to 3x plus 1 is going to be 3x minus 8. We basically put these two things together, right, to get our equation. Right? We took our our slope, which is 3, our m, and our b to get this equation. All right. We're going to do the same thing to a different line in example 4. All right, so I want a line parallel to y equals 1/4 x plus 1 that passes through -4, 2. Okay, so same thing. We're going to look into our line. Is this in slope-intercept form? Yes. Okay, so now I know, well, the slope of this line here is 1/4. So now I need to know, well, what is my parallel slope? It's going to be 1/4. Okay, so I have my slope. I need to find my b. So now I'm going to plug in my x and y. So notice my y is now 2. My slope is 1/4. My x is -4. And we don't know our b. Right? So now when we go through and solve this, we would say, well, 1/4 times -4 is -1 plus b. If we want to solve this for b, we need to get the b by itself. So we would say 3 equals b. So now we have our slope, which is 1/4, and our y-intercept, which is 3. So we can say the line parallel to that line through the given point is y equals 1/4 x plus 3. Okay. All right, here's our last example. And this is what we're going to say is example 5. Okay, we want the same thing. We want a line, right, an equation of a line parallel to y minus 3 equals 2x that passes through the point 5, -4. Okay. Well, now we have to be careful here because we have this equation y minus 3 equals 2x. Okay. In order to get our slope right away, we need to make sure that we get it in slope-intercept form. To do that, we would now say our equation is 2x plus 3. Now I can see my slope of this line is 2, so I know my parallel slope also needs to be 2. Okay. Well, I'm going to use my last box over here, and I'm going to say, well, I know we're going to write this in mx plus b. I have my m. Well, 5 is really my x, and negative 4 is really my y. So now we're going to say negative 4 equals 2 times 5 plus b. So 2 times 5 is 10. In order to solve for b here, we would subtract 10 on each side. Negative 4 minus 10 is negative 14, is our b value. So we put these two things together, and the line parallel to this line here, 2x plus 3 through 5 negative 4, is going to be 2x minus 14. Okay? So notice today's lesson was all about parallel lines. All right? Parallel lines have the same slope, and they do not intersect. Okay? So your homework will be posted. Please let us know if you have any questions, and we look forward to doing tomorrow's video, perpendicular lines. Have a great day. Bye.